Hello, everyone. So this is going to be the first lab for Experimental Statistics 7005. And in this lab, we're just going to do an introduction to R in R Studio. We're going to write our very first R script and basically get a feeling what R is. So R is a statistical programming language, appeared around the 1993. It was built on a previous language called S. And it was built by Ross Ihaka and Robert Gentleman. Those two folks were from the University of Auckland in New Zealand. And the reason why they chose R for the name of the language is because it's the shared first letter of their first names. R is a very popular programming language, especially when you're dealing with statistical analysis. And right now it has extended to a lot more. It is the go-to thing together with Python for data analysts nowadays if you're working with open source free programs. Now, in the previous video that you probably already watched, I showed you how to install R, and I also showed you how to install R Studio. So what is R Studio? And again, R is the programming language that does everything in the background, executes the code, but R Studio is what we call an integrated development environment, an IDE. It's something like a graphic user interface, but with more things. It allows you to basically write R in a clean way, have all the packages installed, have a good output and so on and so forth. So it has a lot of good tools that help you, with writing in R. I do want to mention that R Studios was fully developed around 2011, 2012, and we can definitely see a meteoric rise of R in terms of usage after that. So it really helped popularize R. There are other graphic user interfaces with R, but R Studio is now the default go-to thing. So what are the R libraries? So R on its own is just, the bare bones language, but it's modular, right? Meaning that you can add things to it and extend its functionality. For the gamers out there, think of libraries as mods for a game, right? You have the engine of the game that does something simple, and then you add some functionality. And the good thing is, just like modding, everybody can add to it, like all users with a minimal knowledge of how to create packages can add to R. Now, it's a little bit trickier because there is a repository for R, which is called the CRAN, and there is a process on how to check if your package is, playing very well with others and it's not going to break R. So you could always extend R using an appropriate library, and it can do so many things. For example, the notes that you're reading right now are written in R with the R markdown. There will be a little video about that later on. And there's so many packages out there that at some point you don't know which one to choose. There is a comprehensive set of packages that does a lot of things, and it's tidy. It's actually called the tidyverse. And for this class, I will be using a lot of packages coming from that. We'll see how to install the package today. Now, what is R Markdown, which was mentioned earlier? Well, it's a program, basically a package that extends R and allows us to write things like an HTML or a PDF or a Word document in R. And it's very, very useful, especially if you have like a lot of mathematical formulations and code that runs in the background. You'll see just like how this these nodes were created. And as a matter of fact, in the same folder as you found the notes for the lab, you also found the R Markdown that created those notes. So what I want to do today is, assuming that you are able to install R in R Studio, let's try to go ahead and run our first R code, install some packages, see a little bit how this whole thing works. And let's navigate into our R Studio, which, remember, it will look something like that. And I'm going to move the notes on the side. If it is possible for you to do so, have the notes on the side, copy paste things in, as needed. The very first thing that we need to do is click on the top left corner here in the little plus button. And for now, I'm going to make an R script. Later on, I'm going to, as I said, show you how to do an R Markdown. So let's click on the script here, and you get some, space here to put in your codes. In the beginning, I suggest copy and pasting in the codes that you get from the notes, but later on, feel free to expand. As a matter of fact, Google is your friend. If you need to do something in R, there's a very high chance that somebody else has done it in the past and actually, written a tutorial about it. So what I want to do right now is I want to install our first package. I'm going to be trying to read in an Excel sheet, and that's not something that R does by default. I mean, it kind of does, but there's a much better way to do it, utilizing a package called readxl. So I would like you to basically just copy the first line that you see in the code, or basically copy the line that you see install packages inside the notes. So it should look something like this, copy and paste it in. And what this is going to do is it's going to install the package readxl. And to do that, you need some internet connection. What RStudio is going to do in the background is it's going to connect here to this repository, find this package called readxl, and install it in your computer. So if I click run, so again, in order to execute a command, you copy it inside your script here, you select it and hit run. There are many ways that you can execute a command. There are shortcuts for it. Feel free to explore and find the way that works the best for you. You could be like clicking the end and pressing a thing, it's Control R, but I don't remember it by heart. So for now, the only thing I'm going to do, I'm just going to be selecting the pieces that I want to run and hit this little run button up there. So as you can see down here, we're getting some information. In the console, it's telling us what's happening, where are the packages being installed, and whether or not it's successfully completed it. As you can see here, it is. And right now, the package readxl is already installed. Now, in order for you to be able to see what packages you have and what packages you need and what packages are enabled, you can click down here on the package tab. And these are all the packages that come pre-installed, right? And down here, if I scroll a little bit, I now have the readxl, right? This is the one that I just installed. And basically, this is just readxl files. In order for you to activate it, you can just click on it, or you can go ahead and put here library, and in parentheses, read Excel. All right. And again, you could just copy that from the notes or from the code. So now the moment that we run this line, you will see the tick appear down there as well. This implies that this library is now being activated, right? So we don't activate all packages by default. We only activate the packages that we actually use, all right? And we're going to try now to read in our first data set. The first data set, you can find it again in the same folder as you found everything else. It is called, I haven't downloaded it yet, and it is called, let me go back and download it from here. You can just go to our lab, which should be a link to, let's navigate to here, and let's go to our lab. And if you go to the notes, you will see that in this folder, there's this feeding log xlsx. Let me go ahead and download that. And it is a good idea to save it in a specific folder, right? So I'm going to go ahead. I have created in the desktop a folder called Lab01. So I'm going to go and put that there, right? And since we're at it right now, let's go ahead and save this script also in the same folder. It does make sense to have everything kind of concentrated. To do that, you just have this tab selected and you go back there to File and you do Save As and find where you want to save it. I'm going to save it on my desktop and I will choose the Lab1, give it a name. I guess Lab01 is fine, not very creative. And now this is saved at the same spot as the data is. So in order for us to read in the data, we're going to be using the readxl package and the readxl command. I do have in the notes some information on how to prepare a data set in order for it to, kind of look right. I have created a naming protocol, and check the Lab01 for more information about it. It just, gives you a good idea on how to handle data, like what are going to be the rows and the columns, how can you use, what variable names you can use, what characters you can use, and things like that. And you can find that in the same folder as the codes and the data. It's this thing here. It's the naming protocols. This is by far not the best way to do it, but it is a way to do it. Anyway, so right now what we want to do is we want to read in our data. Okay, let's grab this command, the data frame 1 equals read Excel. Let me plug that in there. The next command in our code. And if I try to run this on its own, it's going to say, I can't find this. You see here down this error, this path does not exist. So basically, we have not defined where R and RStudio should go to find this data set. The easiest way to do it, the way that I've structured it right now, is to go here up on session and then set working directory to source file location. So basically, this tells R and RStudio that, hey, the working directory where you're going to be looking up things is the same as the one of the script here. And since I put the data in the same folder, if I'm going to run this code now, it's going to find it. All right. So now there's going to be this new data frame. So this line says, read this Excel file, which is called feeding log XLSX. And whatever you find in there, define it as df1. This is what this equality sign is. In R, you can also use this symbol to define things, which is, the left inequality with a minus, basically an arrow, left arrow. This will do the exact same thing. And prior to this, here's the name of how you want to call this data set inside R. And this is the command, the read Excel. And basically, you tell it where to apply this command. So basically, read the Excel file that is, named this. And then whatever you get, save it as df1. In R, the main tool, let's say, to handle data is called the data frame. So if you see me type df1, that basically in my head means data frame 1. Where can you find this data frame? Look here on the environment tab. Environment tab, you'll see a df1, and it tells you that I have 48 observations of 3 variables. This basically means 3 columns, 48 rows. Well, 49 rows because the first row is for the variable names. If you click on this, you can actually see it. So you can either left click on this and it pops up here, or you can do things like, open it up here and gives you some basic information, right? You could also click this thing and you get back to that. So play around and try to figure out how you can view this data set inside R. You don't have options to change here manually, but we'll see how you can change things in R later on. For now, let's try to explore what is in there. The first column has the days. By the way, this is an actual feeding log that I had collected information about my daughter. She was born in 2018. And after a little while, we were looking at how much milk she was getting per day and whether or not she had a bath that day. So what you see over here is, their feeding log in ounces. These are the dates, and this is whether or not she had a bath that day. The idea was like, is there any difference with respect to how much she eats based on whether or not she had a bath? And we'll explore that a little bit further. For now, just focus on the fact that this is a numerical variable, and this is a categorical variable, and day is like a time, so it's some sort of ordinal categorical. And when we read it in, now it's available for us to do whatever. The structure also is very important. We want the variables to be, on the columns, and we want the observations to be on the rows. If it's the other way around, it's a little bit tricky for R to handle and do some analysis. All right, so this is how you basically introduce your first data. Feel free to play around with it if you want to do something to it. If you have some ideas on how to proceed, just go ahead and do so. The only thing I'm going to do is I'm going to try to do a very simple box plot out of it. And don't worry, by the end of the week, we will know exactly what a box plot is. But for now, I just want to create like a simple graph for it. Unfortunately, or fortunately, I should say, there is a very nice package that creates beautiful graphs in R. There are some graphs that can be done by default, but most of the times they look ugly. The package that I'm going to be using is called ggplot2. And if you grab the following two lines from the notes and drop them in there, this is going to install again a package, the ggplot2, and also activate it. So we'll wait a little bit until it finds it and installs it. There you go. All right, so now everything is in there. And in order to create a box plot, you have to grab the big chunk of code that you'll find in your notes. And I will try to explain as much as I can. So first of all, again, notice this, this symbol here, this defines. And I defined the graph that is in here in this chunk. I called it P1. Again, not very inventive, picture one. And then I'm invoking the package ggplot. And I am doing some sort of graph that has an x coordinate and a y coordinate. If you'd like, on the x coordinate, I'm going to put the path variable, so there's going to be a yes or no, and on the y coordinate, I'm going to put basically the feeding log. And what it creates is it creates a geometric box plot. And I also want, you know, the error bars, and I want to showcase the means. Don't worry, we're going to get into that a little bit more later on. I can also change, you know, the labels for the x-axis, for the y-axis, and for the title. At the very end, I just need to tell it ggplot, like, how do you want it to look like? And I'm just using the classic theme here. This is a whole code. This is a chunk of code that you need to grab and run at the same time. And if you run only that, just something happened in the background. There's a picture created, but you cannot see it. You see up here that there's a picture created. You can basically like click on this and it just gives you a description of what is involved. In order to actually see the picture, what you need to do is you need to just type its name in there and then run that. So P1, and if you run it, it pops up down here. This is the tab for packages. This is the tab for plots. And basically this is the box plot, feeding quantities, including, you know, means and error bars for my daughter, depending on whether or not she had a bath. Okay, so basically that's it. And if you want to save this so that you can later on see it as a JPEG or a PDF, I have another little chunk of code down here that basically utilizes the ggsave. Again, that's a function inside ggplot that takes whatever you created, in this case, picture one, and saves it inside the same working directory with the name boxplot PDF. And if you use .jpeg, it saves it as a PDF or a JPEG respectively. So if I run this too, and I go back and look into that folder, I will have the boxplot like that. So you can then use this one and put it in some Word document or some presentation and so on and so forth. Okay, now that's all basically for this lab. Again, it's completely an introductory one. Make sure you review this, ask questions. Wednesday's class is all about asking questions. The first couple of weeks, it's going to be a little bit more of an overview type of thing, but in general, you're supposed to watch this lab and then ask some questions on Wednesday and complete the homework. If there is any issue, just reach out to us during office hours or through the through Moodle, and we're going to try to answer as many questions as we can. All right, so I guess that's all for today, and we'll talk soon.